talk something about how we did it, the method, and the evaluation, and last but not least, the conclusion. Okay, like we heard yesterday, we have some special requirements for power stations, not only in China, but also in Europe and all over the world. It's the same to balance the electricity production and the consumption. And this is also a new topic for the hydropower plants. For example, one requirement is the secondary or primary frequency control. The second one is the flexibility to have a wider operating range and to have a power plant which can supply power at any time, and sometimes in case of a pump storage also consume power. This wider operating range results in a higher number of load cycles, and also you have more transient conditions like startup and stops. And especially these requirements affect lifetime of the unit, of the components of the unit, and so we have to face these requirements during the construction phase. And also the knowledge is not detailed into the mechanism inside of a coupler hub. We do not have many measurements to rely on, and this was one main motivation to conduct the measurement. Okay, this slide should describe the measurement campaign, starting with the setup, then the measuring positions where we measured, the evaluation and post-processing, and it should give an overview how complex this measurement was. Just give a number. The whole campaign from installation to conduction of the measurement was a total period of 8 months. And beside that, we had some problems because of the machine was disassembled, and after the assembly we had to run the dry and wet commissioning. And since in the coupler hub you have rotating and moving parts, it's a tough challenge to survive the conditions. Beside that, the runner was filled with water, and we are lucky that we can say, okay, that after the commissioning we had still all sensors left and no one was wrong. Okay, here on the right hand side you see a scratch from the powerhouse. You see, zoom in, we have sensors on the links, we have sensors on the trunnions, and we measured the axial force in the trunnions, and in the links, and in the trunnions we measured bending and the torque. And additionally, we had a temperature sensor inside the hub which was monitoring the water temperature in the hub. Here you see some slides or some pictures about the installation phase. First one started in November 2015 when my colleagues went to the site, and we installed the strain gauges on the disassembled components. Here you see the trunnion where the blade is attached to, and there we installed half bridges compensate the links to compensate the bending and the trunnions to compensate the axial force. The next step was in February 2016. We had to feed the cable through the shaft line from the hub. So we came to the site and supported the guys during the installation of the shaft. For this cabling feed through the shaft, we had to drill an extra borehole, and after that we could feed those cables through. Additionally, we applied strain gauges on the shaft to measure the axial force of the shaft and torque of the shaft. After that, in July 2016, finally the unit was ready for commissioning, ready to run again, and we came there as well to do the installation of the auxiliary sensors like relative and absolute bearing vibrations, pressure transducers, and so on, and we conducted the measurement containment. Here is an example about the test program. We have transient conditions like start-up, stop, load ejections. We have stationary load conditions. We have tested frequency control and some other special governor tests like periodic form of opening and closing the runner, and we also tested the off-cam relation. Here's a sketch about the installation on the link. We had strain gauges on the inner link and on the outer link, and on both sides of this link. So the two strain gauges, we applied a half bridge to compensate the bending in the link. And as you can see, FEA analysis resulted that we had an uneven distributed stress in the link. For that, we had to evaluate the measurement results and compared with a FEA model, and we applied some correction factors to gain a more accurate result. Here you can see the plots, I hope so. They are much smaller than I thought to. But in everyone you can see the first the opening, the second one is the link forces, the third one the bending in the trunnion, and the last one is the torque in the trunnion. And you see on the left hand side startup, right, the stop, load ejection, frequency control, and the load ramp. And which is quite impressive, in my opinion, is frequency control. You can see every moving, slightly moving. You can see it in the, of course, in the links and in the trunnion. Okay, about the conclusion. We applied the sensors, and we were lucky that everyone survived, and we get some good results of this measurement. And with those new knowledge, we can correlate simulation results with the real measured results. And we also had a new experience in a very hard accessible area where the transmission of the signal from the telemetry system, from the rotating system to the stationary system is not very favorable because you have lots of steel and it's not the best conditions to have for a telemetry system. And also the main issue, like I said before, was the long time period. We had to do the planning in the early stage of the outage and to synchronize all the works with our works and to get everything done. And yeah, special field test data, as I said before, are necessary for transient behavior, because for stationary load steps, the FEA model fits quite well to the measured ones, but we had no experience about these transient conditions in runner hub. Okay, that's it up to now. And now it's open for any questions.
Any questions?
You presented your experience in a very smooth way, but I'm sure that you have some surprises in the way to get the results. What were the biggest challenges in these 8 months of preparation?
Like I said, this was my colleagues who did this measurement, but meanwhile we had another measurement in the same country, once also on the Kaplan runner, where we tried to measure also on the plate and also in the hub the lean forces. And the most challenging part is to get all together and to have to be at the site in the right time and to know the exact status of the project, that you can adapt your work and to do your work in the right time. This is
technical challenges.
Technical challenges, for sure there are. Like I said, the telemetry system, the guiding through of the cable through the shaft line, we had to drill an extra borehole. Usually it's not possible to bore a hole through the shaft line, but we managed that. And also we never did it before to have, let's say, loose cables in the hub which can move. And but it came out that it was possible, and like I said, this was a new measurement for us. We never did this before, but the result showed that this is possible to do so. Yeah.
I can say 2 words about challenges. So, as already Simon explained, this kind of measurements are only possible with the client, and also the manufacturing part of our company. They all come together. The clients don't want this measurement, we will never get it, because if you deliver this measurement, it belongs to the customer. So this was also my customer in this case, both together. But the challenges were big. So on site, I was on site doing the testing and to figure out that many parts are not in the drawing. So they had a oil cooler in the pit. It was never shown up in the drawings, and it was exactly in that spot where we have our telemetry. So it was really 1 centimeter free to turn around, and then the unit stops. We want to change batteries, and it stops directly in the middle of this oil pump. You cannot access this manually. So we find ourselves in the generator pit. 5 people try to move the unit because they were not able to start. So a lot of challenges. But you have to start it very slowly. Some of the parts have to be like in the trunnions, yeah? There's a trade-off underneath the ring. They have to move it a little bit. They have to find the way how the cables run out. And we need, of course, we need a specialist from the workshop in the support to find the right hole. This was the problem there. But all this, the team
only sense the feeling what you have by water.
Yes.
Because if you have a single oil farm, oil pipe, so there is no place for it.
Yeah, you have to check the details.
Can you get this?